A few short months after Albert Einstein published his famous theory of general relativity in 1915, physicists studying his field equations were astonished to discover solutions that described what we call today black holes. At these bizarre points in space-time, the laws of physics broke down, with matter condensing to a single point of infinite mass. It took many more decades for additional science experiments and theorizing to definitely prove the existence of black holes. And the first actual black hole, Cygnus X1, wasn't actually identified until 1971. But nevertheless, talk of these cosmic monsters has been a near constant now for more than 100 years. Flash forward to today, and not only have we actually photographed a black hole, but we now know that they're extremely common throughout the universe. There are thought to be millions of them in the Milky Way alone, which is just an average-sized galaxy in the grand scheme of things. And because any sufficiently massive star can collapse into a black hole upon its death, there are billions or even trillions of stars out there in the universe that will one day share this fate. There are then many, many more black holes to come. Pretty much ever since black holes became known to the wider public, many people have been somewhat afraid of them. And it's easy to see why. These things are difficult to understand and almost completely impossible to even imagine, particularly the vast supermassive black holes that lie in the heart of almost every galaxy. But as scary as black holes are, we actually rely on them to keep our galaxy functioning. It's clear that they're an integral part of the universe's entire ecosystem, if it could be called such. But that said, the big question still remains: could a black hole ever threaten us here on Earth? If they're out there in such large numbers in the universe, including throughout the Milky Way, is it beyond the realm of possibility that a black hole might someday wander close enough to destroy not only Earth, but every other part of the solar system as well? Well, black holes absolutely do move through space, just like everything else. There are absolutely no static objects in the universe. From the smallest molecules to the largest stars, everything is swirling and turning all the time. Amid this primordial spinning, clouds of atoms are drawn together, spinning faster and growing denser, until they eventually form the objects we're familiar with. Pieces of rocky debris and metal come together to form terrestrial planets, while fields of hydrogen become gas giants and stars. And in time, stars that are large enough will collapse into a black hole. Throughout all of these different processes, celestial bodies all continue to move. The Earth moves around the Sun moves around the galactic center, and the galaxy itself, including the supermassive black hole at its heart, circles a common center of mass between the Milky Way and neighboring galaxy Andromeda. As for black holes, they can be caught up in all of this in more expected ways, at the center of finely balanced systems. And they can also orbit normal stars themselves, and even other black holes in binary black hole systems. There are even black holes in binary systems very close to Earth. And the closest black hole right now is thought to be just 1,500 light-years away, although this is disputed. Otherwise, the closest would be some 3,300 light-years away. But still, that's relatively close in a Milky Way that's about 100,000 light-years across. The fact that we're here today to watch videos all about black holes proves that all of this happens safely out there, for the most part, at least as far as we're concerned. But there is such a thing as a rogue black hole, and that's where the real danger may lie. Rogue black holes are also known as orphan, nomad, or wandering black holes. They're bizarre, unattached singularities drifting idly through the galaxy without appearing to orbit a larger center of mass. We finally detected such a black hole in early 2022, roughly 5,000 light-years away and moving at about 28 miles per second. The reason it took so long to find these black holes is because they're so isolated. Occupying interstellar space, they don't have bright objects nearby with which they regularly interact. The reason we know of so many binary systems that include black holes is because it's far easier to detect a black hole when it's in the proximity of a star. We can't actually see black holes, so we have to detect them thanks to their effects on neighboring bodies. And this is extremely difficult with a black hole that's gone rogue. Fortunately though, rogue black holes are still supposedly far less numerous than regular black holes that have host systems. Scientists currently estimate that there are only a dozen in the Milky Way, and 5,000 light-years, the distance between us and the first known rogue black hole, is still a long way. Even if this particular black hole were heading straight for us and traveling at the speed of light, which it almost certainly would not be doing, it would still take thousands of years for it to reach us. As this is the first rogue black hole we've definitely identified, it could well be the one nearest to us, and therefore we don't have much to worry about. But on the other hand, it's true that aside from the sheer unlikeliness, there's really nothing else stopping a rogue black hole from someday invading our solar system. The good news then is, if a black hole ever came this close, we'd definitely see it coming. The bad news, however, is that if there was a black hole on a collision course with our solar system, then there'd really be nothing we could do about it. The arrival of a black hole in our solar system wouldn't necessarily guarantee our demise, but the outlook wouldn't be good. A supermassive black hole would be devastating, and even a regular stellar mass black hole would cause chaos. It is possible that a black hole could settle into a regular orbit around the Sun. It isn't likely, though, because even a regular black hole would be more massive and therefore gravitationally stronger than the Sun. The Sun isn't big enough to become a black hole, nor is it big enough to wrangle one. A more likely scenario is that the solar system would reorganize itself around the black hole instead of around the Sun. This would destroy any planet that gets too close, but it would also destabilize the system and could cause interplanetary collisions. No matter the scenario, the arrival of a black hole would badly destabilize Earth's orbit, potentially rendering it uninhabitable. If Earth were pushed too far away from the Sun, it would grow too cold. Drawn too close to either the Sun or the black hole, Earth could become far too hot, radioactive, or both to support life. It's the chaos that an invading black hole would bring to the objects in the solar system that is the real danger. Even if the black hole were somehow able to pass through the solar system and exit it again, continuing to orbit the galactic center, it would have destabilized everything in our system in the meantime, with potentially deadly consequences. Finally, what about rogue black holes outside of our galaxy? In addition to black holes within our galaxy and in others, there could also be black holes that exist between galaxies. In 1997, the first intergalactic stars were proven to exist. Stars that drift through space without being gravitationally bound to a particular galaxy. Previously, it was believed that there were no stars in these dark regions because the materials to form stars don't exist out there. But physicists now believe that intergalactic stars are stars that have gotten lost in a way, stranded out there after galactic collisions that essentially left them homeless. There are probably trillions of them. And remember, where there are stars, there are also black holes, roaming forever through the dark. Suffice to say, intergalactic black holes pose even less of a threat to us here on Earth than interstellar ones do. But they're quite an ominous prospect nonetheless. Like every celestial object, black holes travel through space, and some of them are closer to Earth than others. And that's